Hello everyone, I am Bhimama Bhavikati from Sri Siddheshwara Government First Grade College and PG Studies Center, Nargund. I am studying in BSc first year. I will explain our topic, that is structure, specificity, conditions and applications of organic reagents such as dimethyl in inorganic analysis. The contains his introduction of organic reagents in inorganic analysis. Structure of dimethyl specificity of dimethyl conditions for dimethyl applications of dimethyl. The introduction is in inorganic analysis includes mainly two types of analysis. First one is qualitative analysis, another one is quantitative analysis. Qualitative analysis identifications of constituents. For example, elements or functional groups in a substance. Quantitative analysis measurement of qualitative of particular constituents present in a substance. Reagents is a chemical compound used in qualitative analysis for detection and quantitative analysis for estimation of ions or molecules. The organic reagents are used for organic compounds which find extensive use in analytical chemistry for gravimetric and colorimetric analysis. Organic reagents and inorganic reagents. Generally, organic reagents different from inorganic reagents. Organic reagents are more specific than inorganic reagents. Thus, they can be used to detect a single type of ions in a complex mixture. Dimethyl is used to separate nickel ion from other ion. Organic reagents are more sensitive than inorganic reagents. Traces of substance can be detected by using organic reagents. Dilute solution of nickel ion can be from bright red color with DMG. Organic reagents are more selective than inorganic reagents. If the solution containing carboxide ion and nickel ions in given for estimation, then by using DMG nickel ions can be separated from cobalt. DMG forms complex with only ions. It is highly selective in nature. Dimethylglyoxime. It is an organic reagent used in gravimetric estimations of nickel ion. DMG forms an insoluble complex with nickel ions in alkaline medium. The nickel dimethyloxime is bright red in color. It can be precipitation dried. This is dimethylglyoxime. Structure. Dimethylglyoxime is a dioxime containing two oxime groups. The central carbon chain has two methyl groups attached to the carbon atoms. Bring the oxime groups. The structure can represent this peak. DMG complex. This peak is explain the DMG complex. Specificity of dimethylglyoxime. DMG is considered one of the most selective reagents in inorganic qualitative analysis. High specificity towards nickel. Forms a deep red precipitate only with nickel ion under alkaline conditions. Reaction is felt even at room temperature. Precipitation is insoluble in water, dilute acids and dilute alkalis. Reasons for specificity: steric compatibility with the nickel ion, electronic compatibility, strong chelate effect due to two oxime groups. Hydrogen bonding stabilizes the metal complex. Conditions for DMG. DMG is a bentonite ligand. DMG is a bentonite ligand. Here, each atom of nitrogen of DMG has a lone pair of electrons, and by donating these electrons, DMG forms two dative bonds with nickel ions. Two molecules of DMG donating four pair of four electrons to nickel ion to form four donative dative bonds. 1 mole of metal ions combine with 2 mole of DMG to form nickel DMG complex. This can be prepared by adding the alcoholic solution of dimethyl glyoxime to a hot and slightly acidic solution of nickel compound, and then adding slightly excesses of ammonia solution. The precipitation of nickel DMG is slightly soluble in hot water. After washing, it is dried at 110 to 120 degrees Celsius. When then weighed, the conditions required for DMG reaction. Proper reaction conditions are essential for obtaining reliable result. pH requirements. Optimal pH range 9 to 10, achieved using ammonium hydroxide, ammonium chloride buffer. In acidic solution, DMG remains protonated and cannot chelate. Medium, aqueous alcoholic medium, improves solubility of DMG. DMG dissolve poorly in pure water. Temperature. Reaction ideally occurs at room temperature. Heating may be decompose DMG or disturb the equilibrium. Applications of DMG. Simple laboratory test to industrial quality control. Used to separate those contents from solutions of methyl salts and gravimetric analysis. Used in precious metal refining to precipitate palladium from solution of palladium chloride. Using in the analysis of palladium or nickel its coordination. Used of dimethylhexane as a reagent to detect nickel was reported by L.A. Chugaev in 1905. Applications of DMG in qualitative analysis. DMG is the most famous for its qualitative test for nickel. Applications of DMG in quantitative or inorganic analysis. The nickel DMG complex is extensively used in gravimetric analysis. The conclusion is DMG is one of the most important organic reagents in the history of the analytical chemistry. DMG represents the ideal example of how organic reagents essence inorganic analytical methods through selectivity, stability, and versatility. Thank you.